Okay, so today what we are going to learn is something called compounding periods.
Compounding periods.
Compounding period. It's a very, very important component of compound interest investment. And compound interest is a geometric growth real life scenario. We've learned that.
Yeah.
And what is the formula for the compound interest? Or probably I should say the nth term formula is Vn equals to R, capital R, raised to the power of n times V0. We did that, right?
Yeah.
And we know that V0 is the principal, the starting investment,
Yeah.
the starting value of my investment.
Yeah.
R is called the growth multiplier, and Vn is the value of the investment after n. I will not say now n years. I will not say n years. I will say n compounding periods. And I'll come to what this is in a second.
Yeah.
And n is basically the number of compounding periods that we are dealing with.
Yeah.
Okay. Now, so for now, I will not talk about this n, but I will say Vn is the value of my investment after n compounding periods, right?
Mm-hmm.
Or after certain number of compounding periods. Now, I'll keep it very simple, right? So in this formula here, the R, the growth multiplier, is 1 plus the rate of interest over 100. We know that, correct?
Yeah. Yeah.
Now, I change this formula a bit and I say n 100 times P is the new formula for R. Very, very important. And using this, what we will do is we will change this formula as well, right? N probably for the sake of understanding, I will still say N is number of years so that we don't confuse between N and P. So N
Yeah.
is still the number of years,
Yeah.
number of years, right? I've introduced a new variable called P, and P is the compounding periods. I also call this as, this is my terminology, as the magic figure.
Magic figure.
This is just my terminology, right? That my way of remembering. There's no book calls it magic.
Yeah.
But for now, hold that thought.
Yeah.
Now, let us take an example. Let us say you go to a bank with $2,000
Yeah.
for a compound interest investment. The bank is going to pay you an interest rate R of, sake of simplicity, so we say 12% per annum.
Yeah.
And there's another person who goes to another bank with the same amount of money, and that person is also offered 12% per annum. Now, there is a slight twist in this scenario. Bank one, I'll say bank one, and bank two. Bank one is saying that we will pay 12% per annum, but they now add two words, compounding monthly. Whereas the other bank says compounding annually. Now, at the face of it, it's 12%. Doesn't really matter.
Yeah.
12% is 12%. The deal looks to be absolutely cool, as in equal for both the scenarios.
Yeah.
So let us say after the end of 1 year, how much money is being earned, or what's the final value of this money at the end of 1 year. Now, before we calculate that, let's understand the difference between these two terms. The difference between the two deals. One says compounding monthly, the other one says compounding annually. In very, very layman terms, compounding monthly actually means compounding means applying the interest monthly. So in the first scenario, the bank will apply the interest on a monthly basis.
Yeah.
Whereas on the second case, this means applying interest annually. That means
Yearly.
yearly. Now, let's see what difference it is making on Earth. When we are applying the interest monthly in the first scenario, what is my annual rate? 12%. But it is applying monthly. How many months are there in a year?
12.
12. So that means each month, how much interest will be applied? If in 1 year, you are applying
12,
12%
12% times 12.
divided by 12, because
Yeah.
I'm talking about 1 month, which
Yeah.
means 1% every month.
Yeah.
So 1% January, 1% February, 1% March, go up till December. So you've got 12% being split into monthly interest payments. Is that
Yeah.
right?
Yeah.
But at
Correct.
the end of the day, so basically I'll say from Jan, Feb, March, April, May, June, July, August, September, October, November, December. 1% here, 1% here, 1% here. It's all 1%. 1, all add up to 12%.
Yeah.
Story does not change. The person is still getting 12%. The only thing is this 12% is now split into 12 parts of 1% each. You still get 12% at the end of the day. That's about
Yeah.
it.
Yeah.
Whereas this person here gets the interest gets applied yearly. So that means at the end of December only, 12% is applied. Straight away, 12% is being applied to $2,000.
So what's the difference?
There is no difference is what I'm at the face of it, because the money is the same, interest rate is the same,
Yeah.
compounding monthly, all right, makes sense, but then at the end both of them are still getting 12%.
Yeah.
Now I change the formula a bit for compound interest investment, and we bring in this new variable that we introduced, which is P, and understand what that is. So the new or the updated compound interest formula is VN. Vn equals to 1 r raised to the power of n times p. I'm coming to that. And this r is 1 plus small r over 100 times p over n times p. So your new compound interest formula is this, where we have introduced a new variable called p. Now let's understand what this p is. I said this p was nothing but compounding periods, or I
Yeah.
call it as the magic figure.
Yeah.
Now, p is nothing but how many times, and the most important word is in a year, in a year, the interest is applied.
Yeah.
That is P. Now, how many times have I applied the interest in 1 year? That is P. In the first scenario, can you tell me here how many times have I applied?
12 times.
12 times. Awesome. Whereas in this scenario, just
One time.
once.
Yeah.
So P in this scenario is 12 and P in this scenario is 1.
Yeah.
Let's try to put everything in the formula and try to work it out. What is V1? So N value is 1 because I'm after the end of 1 year. So I'm saying V1 equals to, in the brackets, 1 plus 12 over 100 times 12, bracket close, N times P. My N is 1, 1 times 12.
Yeah.
Whereas here, I will say 1 plus 12 over 100 times 1. My p value is 1 in this case. 1 times 1.
Yeah.
Let us calculate, and this is times $2,000. V0. Can you go into your calculator and check what is the value of V1 here? I mean, at the face of it, both values should come exactly the same because it's
Yeah.
12% being paid. So what is the difference? Let's quickly check. So so pull your CAS out, right? Let's see. Um, I'll say calculate and calculate here. So we had what? We had
V1 equals.
within the brackets we have 1 plus. Let's calculate the V1 here for the first one. I'm calculating this V1,
Alright.
this one. 1
Alright.
plus 12 divided by 100, and I'll put this in the bracket so that CAS does not get confused, times 12, bracket closed, and then I say bracket closed, raised to the power of 12 times 1 is basically 12, right?
Yeah.
And I can say 12, and I say again times 2000, and I press enter. 2253.65. So I get $2253.65.
Yeah.
Let's calculate it for the second scenario. I pretty much copy everything so that I don't have to copy this here, copy, and I paste. And my p value was 1 here, so I will just replace. I'll take 100 times 1 is 100, and my raised to the power is now 1, not 12.
Yeah.
1. Let's see what do I get. I should get the same value at the face of it because I'm earning the same amount of interest. But look here. you get 2240 dollar 2240, which is less than the value that you got here. It is roughly $13 less. If you see, you're earning $13 more here. Why? Simply because you have applied the interest more often.
Yeah.
You're getting my point.
Yeah.
So the idea is no matter the rate of interest in both the scenarios was exactly the same, which was 12%, but the number of times you have applied it has actually made significant difference to the amount that you get at the end of whatever number of years you are after. So
Yeah.
that means more number of times you apply the interest, more money you get. More money you get. Simple. Now, question to you. In this scenario, I said it was compounding monthly.
Yeah.
So what was my p-value?
12.
12. Now, if I say it is compounding weekly, can you tell me what will be the p-value?
How many weeks are there in a year?
52.
Yeah, 52.
So that means p-value is 52,
Yeah.
which essentially means that if I change this question to say compounding weekly,
Yeah.
I will get even more money.
But how come you're getting more money for interest being applied more often? Isn't it, wouldn't it be better if you get interest only applied once and like once every
No,
12
it's
years?
because, good question. It is simply because of the nature of the compound interest. In the world of compound interest, you always get the interest on the previous balance.
Yeah.
So if I am doing monthly application of the principal, if it's compounding monthly,
Yeah.
so let's say in January, you started with $2,000 at the start. In January, let's say you had $2,001, for example.
Mhm.
So in February now, what will happen? You will get your interest, your V0 will now become 2001.
Yeah.
And so your V0 constantly changes. It keeps incrementing. Whereas when you are compounding annually, straight away in December, you are picking $2,000 that you started off with. So your V0 value did not change throughout the year. And your V0 value, the more V0 value is, more the money grows. Why? Because V0 is, and I think I forgot to add uh, V0 here, my bad. So the more V0 you have, more Vn it is. It's as simple as that. The logic is as simple as that. You keep increasing your previous balance and your interest is applied on that previous balance to generate the next balance. So
Yeah.
more often you do it, more money you end up generating. So now if I say 52, let's see how much is the difference when I change my scenario from 12 to 52. So I'll just copy the same value, same stuff here again. And I now, rather than a 12, I say this is 52 now. And this becomes not 12, this becomes 52. You see what's going to happen now. Wow, you got another dollar,
Yeah.
one more dollar extra.
Yeah.
Now I can go even further down. I can compound it daily. You get more money.
Yeah.
And when I compound daily, what is the value of P then?
P,
Yes, if it is compounding daily, what will be
yeah,
the value of P?
365.
Awesome, 365, because the question that you're going to ask yourself is
Yeah,
how many times in a year the interest is applied. So compounding daily means P is 365. Let's try 365 as well. So if I just say copy, yeah, let's see how much 365 is going to make the difference to this total. Another few cents, right? You see, you got another maybe
but like,
30 odd cents, 30 odd cents extra.
what's the purpose of getting interest compounded like that frequently? Like, what's the like general point of it?
General point of that is when you the typical real life example is loan.
Yeah,
When you go to the bank to borrow loan, for example, you've got a mortgage, right?
yeah,
Bank will always apply interest compounding daily because they want to squeeze more money out of you.
yeah,
If
but
if they start compounding you annually or monthly, they will earn
yeah,
less money, right?
yeah,
So the classic example is mortgages, where the
yeah,
money is compounded daily. So you pay interest on a daily basis,
yeah,
right? So that's the classic example. And also, when you're doing compound interest investment, whenever you're investing, in an annuity or a perpetual, not annuity or perpetuity, maybe when you're doing a compound interest investment, one shot investment, you end up earning, if they're compounding daily, you end up earning interest on a daily basis, a
yeah.
little more than any other compounding.
But these
Cool.
like these values, sir, like it's very like little. That's what I mean. Like,
It varies little because your initial investment is only $2,000.
yeah,
Imagine this is $2 million.
yeah, yeah, yeah.
How
Then
much
it'll make a
difference will?
difference. Yeah,
Yes, and no one goes to the bank to deposit $2,000. Obviously, in some if someone has 20,000 or 200,000 or 2 million, you will get a considerable difference the more you compound. So
yeah.
that's what the gist of it. All right, cool. Thank you.